Hello, I am Flash Isaac, and today I shall be taking you through measure of dispersion. Now, data can be separated or spread into measure of central tendency or measure of dispersion. Under the measure of central tendency, we treat the mean, median, and mode. The good news is that in my previous video, I was able to explain mean, median, and mode with a whole lot of calculations. I highly recommend that you watch that video. It is a background you need for this class. The video will teach you how to answer questions under mean very fast, how to find median, and how to find mode for both group and ungrouped data. For today, measure of dispersion. I promise to make this class as simple as possible, as straightforward as possible, as detailed as possible, and as interesting as possible. This is how the class will go. I'll quickly take you through the 4 measures of dispersion. By the way, measure of dispersion simply means measure of spread, and it studies how data spread across the mean value. After going through the measure of dispersion, I'll go straight to calculations. Do you know why? By the time we start talking, explaining, it will not really make sense. But when we start explaining with calculation, you will understand more. It is called practical. The measure of dispersion are range, mean deviation, variance, and standard deviation. Range is simply the biggest value minus the smallest value. If I give you a set of values 3, 5, 7, 8, 1, 12, and I say, what is the range? The biggest value there is 12 and the smallest value is 1. Range is therefore 12 minus 1, that is 11. It is as simple as that. This is why one of the features of range is that it is easy to calculate, and it considers the 2 extreme values only. With this, we can say that range is not a good measure of dispersion because you have so many values, you look for the 2 extreme ones, you give the answer. Is that a good measure of dispersion? No. And range is used in quality control for products. When you have a lot of products, you try to look at the range, the deviation. You look at this, you look at that. If there's a lot of difference between one and the other, or the highest and the least, you therefore have to reject that product because the range should be very, very small. This takes us to mean deviation. Mean deviation generally tells us or generally explains how far on average all values are from the middle, or how far on average values are from the mean. Remember, the measure of dispersion generally treats how values spread around the mean position, and the mean is the average of values which we've already dealt with or which I already treated in the previous video. And to find mean, it is simply summation of absolute value of s minus s bar over n. This is the value, or this is the formula for finding mean deviation. And like I told you, I won't be doing much talk. While solving questions, I will explain what everything means and how to use them, so it will really ginger you. A feature or character of mean deviation, it involves all items in the data. If you are given a set of values and asked to find the mean deviation, you will therefore use all the values given to find mean deviation, unlike range where you need the 2 extreme values only. The mean deviation is difficult to investigate how it behaves as it treats the positive values. So you can't really investigate how it behaves because the deviation is treated as positive values. For example, you see the summation of s minus s bar, we are given the absolute value. So absolute value means If you solve and here gives you, let's say, minus 20, you will remove the minus. We don't deal with negative numbers in absolute value. So when you finally get an answer, you won't know whether it's positive or negative because we took the absolute value. And variance is the average of the squared of the mean from the elements in the data. Squared distance of the mean from elements of the data. Now, variance is summation of s minus s bar squared over n minus 1. Look at this. Deviation is summation of s minus s bar, absolute value, but variance treats the summation of s minus s bar and it is squared. So variance is therefore squares the actual observation, and it's the measurement of spread between numbers in the data set. How numbers spread. Then the standard deviation. The standard deviation is simply the positive square root of variance. If you are asked to look for variance and standard deviation, if you are able to get the variance, the square root of that variance is your standard deviation. And standard deviation is simply the square root of summation of s minus s bar squared over n minus 1. The value given, total values minus 1, the number as you will see later. Now, samples with the same deviation have the same variance and standard deviation. These are properties of standard deviation and variance. Then standard deviation measures how much members of the group differ from the mean value. That is the goal of measure of dispersion. How values deviate or disperse from the average value. Now that we know that, the measures of dispersion are range, mean deviation, variance, and standard deviation. How do we solve real life questions under variance, under mean deviation, under standard deviation, and under range? So let's see the various type of questions. Group data, ungrouped data, how to answer them. Range of data. The first question says the range of 4, 7, 6, 8, 17, 2, and 18 is dash. Anytime you hear range, this thing should ring in your mind. Biggest minus smallest. If range is simply the biggest value or the biggest number minus the smallest number, we look at these values. What is the smallest number? By inspection, the smallest number is 2. And what is the biggest number? From inspection or by inspection as well, the biggest number is 18. The range is therefore 18 minus 2. This is equals 16. So that is the range of the values. Solving questions on that range is usually very, very interesting. Look at the next question. It says, find range of the numbers minus 1, minus 5, minus 3, 1, 4, 5, 3, and 6. Range still remains the biggest number minus the smallest number. This is where the question comes. What is the smallest number among these values? And what is the largest number in the data? Minus 1, minus 5, and minus 3. So, and 5, which is bigger? When you take a look at the number line, the middle is 0, then 1, 2, 3, 4, 5, and so on. As you move this way, you have minus 1, minus 2, minus 3, minus 4, minus 5, and so on. So 0 is the middle of numbers. If you move towards this side, towards your right, the value increases. This means 5 is bigger than 4, 4 is bigger than 3, 3 is bigger than 2, and 2 is bigger than 1. As you move towards this side, your left hand side, the values become smaller. This means 0 is bigger than -1, -1 is bigger than -2, -2 is bigger than -3, and -3 is bigger than -1000. From this, we therefore conclude that the smallest value here is -5. So smallest. And the biggest is equals 6. So biggest is equals 6. And range is biggest minus smallest. So biggest minus smallest. So what is the biggest? 6 minus what is the smallest? -5. So the smallest is -5. So don't fail to put only one minus and say 6 minus 5. No. This is the biggest minus already in the formula, and the smallest has its own minus, -5. So this gives you 6 minus minus, that is minus times minus. It gives you plus. Then 6 plus 5. This will equals 11. So 6 minus -5 will give you 11. Try that on your calculator if you still don't agree with me. So the range of the values equals 11. And let's see the third question. The third question says, find the range of 1/6, 1/3, 3/2, 8/9, and 4/3. A question comes to mind. Which of the numbers is the smallest and which one is the biggest? So when it comes to fraction, it normally looks confusing. If you already know the biggest and the smallest from inspection, very good of you. But if you don't know, use this method. Look for the LCM of the denominator. The denominators are 6, 3, 2, 9, and 3. So let's see their LCM. LCM of 6, 3, 2, 9, and 3. 2 can go. 2 here, this gives you 3. 3 remains. 1, 9 remains. 3 remains. If by now you don't understand how to look for LCM, I'll share a video with you on how to find LCM. Flash Learners LCM video. It will enable you understand LCM very, very well. So up next, 3. 3 divided by 3 is 1. 3 divided by 3 is 1. 1 divided by 3, 1 remains because we don't deal with fractions while finding LCM. 9 divided by 3 is 3. 3 divided by 3 is 1. So 3 goes again. 1 remains, 1 remains, 1 remains. 3 divided by 3 is 1. 1 remains. Therefore, LCM is equals 2 times 3 times 3. 2 times 3 is 6. And 6 times 3 is what? 18. So the LCM is 18. Now that we've looked for the LCM, let's use the LCM to multiply each of the numbers. From there, we should be able to get which is smaller, which is bigger. Let's start with this. This becomes 1/6 times 18 equals, this becomes 1/3 times 18 equals, this becomes 3/2 times 18 equals, this becomes 8/9 times 18 equals, this becomes 4/3 times 18 to be equals. Now 6 divided by 18 divided by 2 is 9. 6 divided by 2 is 3. 9 divided by 3, that is 3. So 1/6 times 18, this will give you 3. Then 18 divided by 1 times 18 divided by 3, this will give you 6. So these are the values you will get. Now out of these values, what is the smallest value? The smallest value is 3, and 3 corresponds to 1 over 6. That means 1 over 6 is the smallest value. The biggest value is 27. And what does 27 correspond to? 3 over 2. That is 3 over 2. Which means the biggest value is 3 over 2 and the smallest value is 1 over 6. 3 over 2 minus 1 over 6. LCM is 6. 6 divided by 2, 3. 3 times 3, 9. So 9 minus 1 is equals 8 over 6. And that should give you 4 over 3. So the range of this set of values is 4 over 3. And the next question says, the table above shows scores of 20 students in mathematics test. Obviously, find the range. So we are asked to look for the range of the score. The range of the scores simply means the biggest score minus the smallest score. The biggest score is 10. The smallest score is 3. So the range is simply 10 minus 3. That is 7. So the range of scores is 7. And the final question on that range says that find the sum of the range and mode of 2, 3, 5, 9, 3, 3, 0, 12, and 8. The sum of the range and the mode. The range is the biggest minus smallest. The biggest out of them is 12. The smallest is 2. So 12 minus 2, 10. That is the range. And the mode is the number that appears more. Looking at here, 3 appears more. So 3 is the mode. So the sum of the range and mode is 10 plus 3. That should give you 13. I hope you found these explanations and calculations helpful. And I hope with this, you are able to understand range better and able to know how questions are set under range. Now let's see the next one. Find the mean deviation of 4, 5, and 9. 4, 5, and 9. When you are given questions in statistics or measure of dispersion, just relax, don't be in a hurry. Take things one after the other. If you notice in this class, I have been gentle, calm, trying to analyze as slow or as quick or as steady as possible. This is what statistics require. If it were other classes, you will see the way I'm explaining with ginger. But statistics requires maturity. Otherwise, you'll be surprised how you will fail questions. Now, find the mean deviation of these values. This can be as many values as possible. It may be 4, 5, 9, 10, 15, 20, 17, 18. No matter how many they are, this type of values or data are referred to as ungrouped. So while the ones you see in table are referred to as grouped data. So for ungrouped data, no matter how many they are, this is what you do for mean deviation. Remember, mean deviation is summation of absolute value of s minus s bar all over n. What is n here? N is simply how the values you have. How many values do we have here? 4, 5, and 9. That is 3. So which means n is equals 3. We already have that. To calculate mean deviation, we need s. And what is s? For ungrouped data, each of the values or each of the numbers represents s. What s? We need s bar. S bar is the mean. So which means if we can get s bar, we have every other thing, we look for their summation. For this ungrouped data, to find the mean or average, this is simply 4 plus 5 plus 9 over 3. Mean of ungrouped data. You add up the numbers, you divide by how many they are. 4 plus 5 is 9. 9 plus 9, 18. So 18 over 3. That is the mean. What is 18 over 3? 6 plus 6 is 12. Plus 6, 18. So 18 over 3 is 6. The mean is 6. Now, summation simply means add all the values of s minus s bar. Mean deviation will simply be the first s minus s bar. S is 4. Remember, we are dealing with absolute value. S is 4 here, minus s bar minus 6. This is the first instance of s minus s bar. We're adding, remember, summation of s minus s bar. We are summing all the s minus s bar. The second s is 5. So 5 minus s bar is 6 plus. We have another s, 9. 9 minus s bar 6. So all over n. What is n? 3. Now, if here were so many values, no matter how many they are, write out each of them, subtract the mean plus another number minus mean plus the third number minus mean plus the fourth minus mean, and so on, no matter how many they are. That is it for all cases of ungrouped data. Now we have that mean deviation is equals 4 minus 6. Mean deviation of grouped data. The formula remains the same. What is S? S is simply each of these value, each of these mark. These are S for group data. While frequency is referred to as F, you will see the use of frequency very soon. The next value we need is N. So for this group data, what is N? N is simply the summation of the frequency. That is N. Because frequency here means 2 persons had 4 marks. Here means 4 persons had 5 marks. So these are the number of persons. That is N, the total number. So 2 plus 4 plus 0. This is 6, 9, 11, 12, 19, 24. So the total number, summation of F is equals N is equals 24. So we've gotten N and we know what our S's are. From my previous video, statistics, mean, median, and mode, I was able to explain that mean for group data is equals summation of Fs over summation of F. This is how to find mean for grouped data. This is a grouped data. For ungrouped data, you simply add up the number, you divide by how many they are. Now, this is what I normally do to find mean of group data to make my calculation neater. I create the first line, it will be for S. And what are the S's? Your S's are 4, 5, 6, 7, 8, 9, 10, 11. These are your S's. And what is your frequency F? F's are 2, 4, 0, 3, 2, 1, 7, 5. Now, remember we need summation of Fs, but before then we need Fs. Fs is simply S times F or F times S. What does that give you? 4 times 2 should give you 8. 5 times 4, is that 20? 6 times 0 is 0. 7 times 3 should give you 21. 8 times 2 should give you 16. 9 times 1 should give you 9. 10 times 7 should give you 70. Then 11 times 5 should give you 55. So everything here is 199. And mean is equals 199/24. That is 8.3, which is summation of fs over summation of f. Everything fs over f will give you that. Look at something very, very important. I've been saving it until we get here. We've been dealing with ungrouped data. Now that we've gotten to group data, there is something different. For group data, mean deviation is equals summation of fd over summation of f. That is mean deviation for group data. Summation of f is simply n. N is now summation of f, which is 24. Summation of fd is you multiply the frequency by the deviation. Deviation is s minus s bar. So if you're able to look for s minus s bar, then we multiply it by f. So that will give us df. S minus s bar is the same thing as d, which means mean deviation is the same thing as summation of d over n, because d is the deviation. So in summary, for mean deviation of group data, you look for summation, you use f to multiply d, then n becomes summation of f. Those are the two modifications. No need for long talk. After solving this question and the next question, you understand perfectly. So s minus s bar, here is s, here is s bar, 8.3. So s minus s bar is, here is, remember in mean deviation we deal with absolute value, we don't deal with minus, so you arrive at positive values. So here is 4 minus 8.3, here is 5 minus 8.3, here is 6 minus 8.3, here is 7 minus 8.3, here is 8 minus 8.3, absolute value. Here is 9 minus 8.3, here is 10 minus 8.3, here is 11 minus 8.3. So the values should be here. D, which is something as s minus s bar. So we do this subtraction, we put the values here. Then here will be fd. So the frequency times each of the values of d. So let me drop them out. So look at it. This is s minus s bar. That is something as d. S minus s bar, which is 8.3. 4 minus 8.3 is 4.3. 5 minus 8.3 is 3.3, and so on, to save time. Then fd is f times d. So f here is 2, d is 4.3. 2 times 4.3 is 8.6. 4 times 3.3 is 13.2, and so on, to save time. So at the end, the sum of fd is 52.4. What is mean deviation? Mean deviation for group data is equals summation of absolute value of fd over summation of f, which is 52.4 over 24, which is summation of f. That is approximately 2.2, which is supposed to be 2.18 something. So 2.2 is the mean deviation. In summary, the next question will make you understand better. Here we are calculating the mean deviation. These are the tomatoes. These are the baskets. So this is, you can refer to this as the frequency, because in 10 baskets we have a particular range of tomatoes, 21 to 25 tomatoes. In 12 baskets, 26 to 30 tomatoes. Now look at something. Comparing this to this mark here is supposed to be the s, then here is supposed to be the frequency, but the s is in range. This range we call that class interval. To get one value of s, or to get exact value of s, we convert class interval to class mark. Therefore, class mark S for this one is 21. This is not minus, this is 2. So class mark for this is 21 plus 25 over 2. You look for the average. Here is 26 plus 30 over 2. Here is 31 plus 35 over 2. Here is 36 plus 40 over 2. Here is 41 plus 45 over 2. So you change the class boundary to class mark. Anytime you see something like this, you change it. So S here becomes, for here, 21 plus 25, that is 46. 46 divided by 2, that will give you 23. 23. And so on. Here is 56 divided by 2. That is 25, 22, 25, 26, 27, 28. 28. Here is 66 divided by 2. This is 33. Here is 76 divided by 2. 35, 36, 37, 38, 38. Here is 86 divided by 2. That will give you 43. So we've gotten our S from the data given. And the baskets we take out to be our F. So F is 10, 12, 5, 4, and 2. If that is true, it simply means that here is our summation of F. And summation of F is 10 plus 12, 22, 27, 31, 33. So we've gotten our summation of F, and this is a group data. For group data, mean deviation is equals summation of absolute value of FD over summation of F. Now, I told you D is this all, F here, F is outside, D over summation of F. And I told you that D is the same thing as everything here. Summation, absolute value or summation of S minus S bar is D. So everything there is D. So summation of FD over summation of F, which is the same thing as summation of FD over 33 in this case. What else? We need to look for the S bar. And S bar, which is mean, is equals summation of Fs over summation of F. What is Fs? Let's look for Fs. Fs here is 23 times 10, 230. So the mean is 29.4. Now that we've gotten the mean, the next thing is to look for the deviation. What is deviation? It is simply D or S minus S bar. Here is S, S bar is 29.4. If we say 23 minus 29.4, that will give us S minus S bar or D for each cases. That is the next thing we shall do. So S minus S bar, 33 minus 29.4 is 3.6. And what is FD? FD is frequency times the deviation. For example, 10 times 6.4 is 64. 12 times 1.4 is 16.8. You simply multiply, you get your values. So when you add 64 and 16.8 and 18.0 and 34.4 and 27.2, you get 160.4. So this value now is the sum of FD, which is 160.4 over sum of F, 33. This will give you 4.86, approximately 4.9. So the mean deviation is 4.9. So go over it again, and one thing I will advise is copy out each of the questions, solve over and over again to see if you really understand. It is highly recommended. Alright, now we are at variance and standard deviation. They actually work together. Don't forget, variance is equals summation d square over n. What is d? D is s minus s bar. So variance is summation of s minus s bar all squared over n for ungrouped data. Standard deviation is the square root of variance. Once you are given a question to find standard deviation, if you are able to get the variance first, the square root of the variance will give you the standard deviation. If you are given a question on standard deviation, if you are able to get the standard deviation, if you square the standard deviation, you will get variance. They work that way. Now, for grouped data, the ones that are grouped, it's the same thing as what we did earlier. For group data, variance will simply be summation of f d square over summation of f. Standard deviation will simply be square root of summation of f d square over summation of f, where this is s minus s bar. We are asked to find the variance and standard deviation of 5, 6, and 7. So no matter how many they are, so long they are on group data, whether they are 7, 8, 10, 15, whether they are so many or they are not many, short or long, we use the same method. We are given the mean to be 6. At this stage, we shouldn't be looking for mean up and down. So we are given the mean to save our time. I actually gave myself the mean because finding the mean of this over again doesn't make sense, or finding the mean of this doesn't make sense again, because we've done that since, and there's a dedicated video for mean, median, and mode. But so that you master the use of class mark, I will solve for the mean in this one. Now let us begin. Standard deviation, or variance, let's begin with variance. Summation of s minus s bar square over n. S is simply 5, 6, and 7. And we've gotten our s bar to be 6. So s minus s bar is simply 5 minus 6 is minus 1. 6 minus 6 is 0. 7 minus 6 is 1. That is s minus s bar. But in variance, we are to square the s minus s bar. Therefore, s minus s bar squared, which is the same thing as d squared, is 1 squared is 1, 0 squared is 0, 1 squared is 1. So summation of d squared, or summation of s minus s bar squared, is equals to 1 plus 1. What else? N is, how many are they? 1, 2, 3. We have 3 values. So n is equals 3. With this, I think we have everything we need. So variance is equals the sum of s minus s bar. The summation of s minus s bar squared is here, s minus s bar squared. Sum, everything gives you 2. So 2 over n, we have 3 values. So the variance is simply 2 over 3. So when you are given on group data, if there are many or not many, no matter how many you are given, put the s down, then find the mean s minus s bar, then find the mean s bar, then look for s minus s bar. Subtract each of the value of the s from the s bar. In this case, 5 minus 6 is minus 1, 6 minus 6 is 0, 7 minus 6 is 1. Then the next, look for s minus s bar squared. Whatever you are given here, square them. Then add everything to give you summation of s minus s bar squared, or summation of d squared. Then your variance is the summation of d squared over the number. That is variance for ungrouped data. The standard deviation is equals square root of variance, which is equals square root of 2 over 3. It is as simple as that. Now let's look at the grouped data. For the group data, we are given class boundary. And I told you that once you are given class boundary or interval, class interval, to look for the class mark or exact value of s, you look for the average of each of them. And I also told you that this is not minus, it's simply to. So the average is 1 plus 3 over 2. Here, 4 plus 6 over 2. Here, 7 plus 9 over 2. So S here is 4 over 2, 2. 4 plus 6 is 10 divided by 2 is 5. 16 divided by 2, that is 8. So that is S. What S? F. So we have F here. 5, 8, 5. That is the value of F. Then S bar. S bar for group data is equal to summation of Fs over summation of F. What is Fs? In this case, let's look for Fs. Fs. 2 times 5, 10. 5 times 8, 14. 8 times 5, 40. So everything here is summation of Fs, and that is 80, 90. 90. Now, what is summation of F? Summation of F is everything here, 18. Let's look for S minus S bar. So S minus S bar is simply 2 minus 5, that's minus 3. 5 minus 5 is 0. S 8 minus S bar, 8 minus 5, 5, 6, 7, 8, that is 3. You observe. Then S minus S bar squared, or D squared, this is the same thing as D, minus 3 squared is 9. 0 squared is 0, 3 squared is 9. So adding everything here is summation of D squared, and that is 18. So we've gotten summation of D squared, we've gotten summation of S, and we've gotten our summation of F to be 18, summation of D squared to be 18. What else do we need to find variance? Variance is summation of F, then D squared over summation of F. So we have summation of F to be 18. We have each of the D squared already. So let's use each of the D squared to multiply F to give us FD squared. So here is 5 times 9. 5, 10, 15, 20, 25, 30, 35, 40, 45. So this is 45. F this here. D squared is 0. So here is 0. Here F D squared. F is 5. D squared is 9. 5 times 9, 45. Therefore, summation of F D squared is equals 90. So the variance will simply be 90 over 18. That is your variance. So 45 divided by 9 is 5. The variance is equals 5. But remember, we are looking for standard deviation. And like I told you, it is not very much different from variance. You look for variance and you say that standard deviation is equals the square root of variance. So the square root of 5 is your standard deviation. But if you are looking for the standard deviation directly, you still follow the same method. At the end, you find the square root. So nothing much. Or if you are looking for the standard deviation directly and you don't want to mention variance, it is very possible. You do this once normally. Look for F, Fs, D, D squared, F, D squared. Don't mention variance. Just say looking for standard deviation. Then at the end here, you simply say that standard deviation is equals summation of F D squared over summation of F, and that is the square root of 5. So it is the same thing. Whether you mention variance, you are not mentioning variance, you solve them the same method. Which means instead of doing without square root, you always put square root. So that is basically it. Then for here, we are looking for variance. We have the mean already. So what do we do? The S is 1, 2, 3, 4, 5. F 2, 1, 2, 1, 2. Then variance is summation of s minus s bar squared over n. S bar is 3. So s minus s bar is 1 minus 3 minus 2, 2 minus 3 minus 1, 3 minus 3 0, 4 minus 3 1, 5 minus 3 2. This is d. So d squared or s minus s bar squared is minus 2 squared is 4, 1, 0, 1, 4. So summation of d squared is equals 4 plus 4 8 plus 2 10. So 10 is summation of d squared. Then let's find fd squared. Fd squared will simply be 2 times 4 8, 1 times 1 1, 2 times 0 0, 1 times 1 1, 2 times 4 8, 8 plus 8 16, 16 plus 2 18. So summation of fd squared is equals 18. So summation of fd squared is 18. Variance is therefore summation of fd squared over summation of f. Summation of f is everything here, and that is 2 4 6 8. 8. Summation of f is equals 8. So your variance is 18 over 8. If you're looking for standard deviation, it will be the square root of 18 over 8. 18 divided by 2 is 9. 8 divided by 2 is 4. So here is the same thing as square root of 9 over 4. Ladies and gentlemen, measure of dispersion, range, mean deviation, variance, and standard deviation. I trust you found this class helpful. Feel free to share with others, and don't forget to let me know how you feel using the comment box. Subscribe to this channel and tell your friends to subscribe. More videos coming, and check out my other videos across other subjects. You will definitely find something very, very helpful. Thank you.